Hi everyone, this is Billy. Last year I've created a dishwasher proof of concept using a garden sprayer with a heavy duty pump, and the powerful pump is okay to spray enough water in strong forces to remove dirt on the surfaces of the dishes, and this will become a dishwasher. However, I stopped working on that project for a year now, and recently I've picked up this project again, and I've created a program and this setup to drive the pumps, the heaters, the drain pumps, and other sensors to create the dishwasher. Let's take a look at the circuit for the ESP8266 dishwasher. So we are using this Nook MCU D1 Mini as the controller. It has the capability to connect to Wi-Fi. So next step, we may change the program to allow the dishwasher to be controlled by the web. But right now, let's just start with simple, just control by this one single button. This button is connected to the A0 analog to digital converter input, and we also have the display OLED 128 times 64 pixels. So it's driven using I2C, so we connect the two I2C pins, SCL and SDA, to this display. Then we also have this water level temperature sensor. It is DS18820. So I take this one because this one is sealed in a steel tube that can be immersed into water and can sustain high temperature up to 155 degrees Celsius. So it's connected to one of the pins here. Then we have the water level sensor. Water level sensor is just a chopstick with 3 wires marking the bottom of the tank, low water level and high water level. So we just connect the wire to the bottom of the tank to ground, low water level to this pin D7, high water level to this pin D5. And then lastly, we have the relay module. If you can buy the 4-way relay module, a single board with 4 relays, then just get that. Otherwise, you can use two-way relay module and stack them up like this. You need to purchase the one with a low activation voltage because we are only going to drive it by 3.3 volts. And you can differentiate the low activation voltage ones versus the not so low level voltage ones by checking if you got this type of opto cupola. So they have the LED and the sensor in one chip, so it can kind of isolate the current from the ESP8266 against the current of the one that's driving the relay. So it can allow you to activate it using a 3.3 volts instead of 5 volts. So otherwise it won't work for ESP8266, so be careful you buy the right relay module. Our relay module connects to the pumps, and the pumps get the supply from the mains electric power. So in Hong Kong, we use 220 volts. In some other countries, you may be using 110 volts. So it doesn't matter as long as you connect one of the wire to one end of the pumps and another wire to the power switch, and then to the relay, to the selector input of the relay. And then the relay's on output pin will be connected to each of these pumps. So let's see what pump we have. With the drain pump, it is a low power pump, those you use in the aquarium, fish tanks. So it can be 10 volts or even less. It's driven by mains power. The second pump is the powerful wash pump. We need a very strong current of water spraying on your dish to remove the dirt. So you need to get a very powerful pump, at least 80 volts or above. Otherwise, it may not have enough power to remove the dirt. And then we have the solenoid. It's like guarding the water inlet jack, inlet gates to allow the water from the hose to flow in to fill the tank. So this type of solenoid usually find in the washing machine. So you can buy the parts from the washing machine. And then we have the underwater heater. So the underwater heater is those people use in the bathroom. If you don't have a heater in your bathroom, they will put this underwater heater. It's like a tube plugged into electricity, and then it will heat up the water before you go in to the bath. But you have to remove it before you jump in, otherwise there's a chance that you may get electricity shock. So this type of underwater heater cannot heat dry, so you must have some water inside. And it has a very high power rating, 1200 volts. So that means we need to ensure our relay is able to sustain this power. So I choose the 10 ampere relay, or you can find the 13 ampere relay, which is even better. But 10 ampere is enough. Okay, and to drive our controller, we need to convert the mains power, 220 volts or 110 volts, down to 5 volts DC. So you can buy this type of small power supply in different ways. So you just feed the 5 volts DC into your NUC MCU's 5 volt input. It will then lower it down into 3.3 volts to supply all the components in the circuit. Okay, now let's look at the program. I've uploaded my program source and the wiring diagram you just seen into my GitHub. So you can go to my GitHub to download it. Here's my GitHub, bx/dishwasher. So you can go there. You can see this FreeSync wiring diagram and the circuit diagram. Also some description how this thing works, right? So this is a dishwasher controller program. It utilizes the ESP8266, Wemos D1 Mini, and SSD1306 I2C LED. The dishwasher function includes the following programs. The normal wash will take you around 90 minutes, including heating the water to 70 degrees Celsius with the heater, and then drying it afterwards. The long washing will add more wash cycles, so draining and washing, draining and washing, multiple cycles to make it clean. So it takes longer, about 3 hours. Fast cycle will be around 1 hour, and so on. The washing test is just for me to test my program. I/O test will cycle through the relays and turn them on and off, and also read off the sensor, so you know which part is not working. So to operate the menu, you just press it quickly, less than half a second to select the option, more than 1 second long press to execute an option, or enter an option. And the LED will go to sleep mode if it's not pressed for a while to save some power. Due to limitation of the ESP8266, there's not many pins we can use. Let me show you. So this is the ESP8266. Only the pins labeled in white color can be used, and then the first two, GPIO1 and 3, are the transmit and receive that used to program your chip, so you can't use that. So there's actually only from D0 up to D8, only 9 pins can be used. But then D1 and D2 are reserved for talking to the OLED. They are the I2C interface pins. So -2, we end up with only 7 pins we can use. So there's not much we can do in terms of input and output. That's why we can't do a lot of function unless we expand it using the I2C expander. For example, the MCP23017. However, I want to make this simpler, so I don't want to add another IC or I2C expander. So we'll have to just do whatever we have. So we can only connect the drain pump to D0, the wash pump to D4, the inlet, that is the solenoid to control the hose for water in, connect to D3, and the heater connect to D8, and then the 2 other pin SCL, SDA connect to the I2C interface for the OLED. For the input, we have to use the A0, the analog to digital pin, to sense the button. And then we use the other 3 pins, D5, D6, D7 in this way. D6 is for the temperature, water level, water temperature sensor. D7 is for the low watermark sensor. D5 is for the high watermark sensor. Okay, let me show you the program. I've tested it for almost several months, so it's very bugs free. So you can just try it out yourself. We use some libraries like the one wire and the temperature sensor library. We also use the OLED driver for SSD 1306. I think that's the only library that we use. The others are just simple stuff. So you can take a look and download it from my GitHub and try to test it with an ESP8266. So let me do a demonstration of the program. This is the SSD 1306 OLED. Dishwasher program is running. We can select different wash programs that represent similar wash program in the commercially available dishwasher. So you can have the normal wash cycle, will take you 1.5 hours. The long one, 3 hours. The fast one may be 1 hour. The fruit program allows you to just spray cold water to the fruits or vegetables and wash them. The spray only will spray hot water on anything you put in the washer. The cold program will not power up the heater, so you can wash your delicate dishes without worrying that it will damage by heat. The wash test is just for me to debug my program. It's an accelerated test. So 1 minute will be reduced down to 1 second, so I can go through the different cycles quickly. The I/O test is for me to test the hardware. That means the pumps, we will turn on the pumps, turn off the pumps in each second. And let me look at these sensors. So to operate this menu, there's only one button. This button is tied to the analog to digital converter pin A0 here. And when I press quickly, it will cycle through the different menu options. And if I press, hold it for 1 second, it will mean I selected the menu. Now it's doing the testing. You can see that the different relay modules driven by this program is going on and going off as I test each of the I/O, the drain pump, the water inlet solenoid, the wash pump, the heater, and the drain pump. So you will go through that in cycle. And there's a water temperature sensor. It is the Texas Instrument DS12 module. So if I put my finger here, you see temperature start to rise to over 30 degrees. And to detect the water level, I use a plastic chopstick. I have a few wires. The bottom wire represents the bottom of the tank. It is connected to ground. The second wire represents the low water mark. So it is the marker that the drain pump will sense. When water goes below this mark, drops below this mark, that means all the water has almost been pumped away and the drain will stop. The high level watermark is this one. It is used to detect if we have filled in enough water. So I just mark it here. So this bottom one is connected to the ground wire. This one and this one connect to the representative pins of the ESP8266. So let me show you. You can see now the L means low watermark is 1. H means high level watermark is 1. Also 1 means it's off. That means nothing connected. But if I start immersing into this bowl of water, if I start immersing this water level sensor into the bottle of water, you see now we are at the low water mark. L becomes 0. If I take it out, L becomes 1. Drop it in, L becomes 0. And then if I continue to immerse into the water, the H high level watermark becomes 0. If I take it out, it will become 1. But the low watermark is still 0. That means we are at the level between the low watermark and the high watermark. So I programmed the software to stop filling up the water tank when H equal to 0. And after washing a cycle, we will drain all the water, and I programmed the drain pump to stop working after there's no more water. That means the L becomes 1. Now to stop testing, I just long press this button and it will be going back to the menu. So I can select return, and then I can select a different program again. So let me show you a wash test. So I'll long press the wash test button. I need to start. So it's now starting. So it's draining. Now it's filling. So I need to drop the sensor into the water to complete the filling of water. Now the pump is washing. The wash pump is on. So it's now washing. Now it's draining. So I need to take out the water sensor. Draining is finished. Now it's filling. So I need to put it in again. Now it's draining again. Take it out. Now it's drying. So the program is now complete. You can go back to the main menu. So this is how it works. And next week, in part 3, I'll share with you how I hook it up together and actually run the dishwasher. Thanks a lot for watching. If you like my video, click like, send to your friends to watch too. Thank you.